So here number 50, the first thing I pay attention to is what is my parent function, and I look that my parent function is sine x. Now the amplitude is still going to be 1 like a regular sine x function. My period is 2 pi over 1, which is 2 pi. But this subtracting of 2 pi means I'm going to shift right 2 pi units. So that means if I'm sketching this graph, right, my amplitude's going to go up to 1 and down to -1. And instead of starting here at 0, I'm going to start over here at 2 pi because I'm shifting everything to the right 2 pi. Now, if my period of 1 full revolution is 2 pi, I add 2 pi to this 2 pi to make 4 pi. Now, within that period, it's broken into 4 subintervals. First, I split it in half, 3 pi. The middle of 2 pi and 3 pi is 2 pi plus 3 pi divided by 2, 5 pi over 2. The middle of 3 pi and 4 pi is 7 pi over 2. Now I can sketch my first period. Now I know from memory that the first point from sine starts at 0. Then it's going to go up to my maximum at 5 pi over 2, 1. It's going to come back down to my 0. It's going to go down to a minimum of 7 pi over 2, -1, and then back up to 0 at the end of the period. So that's 1 full period. Now I want 2 periods, so I'm going to add another 2 pi to this. That's going to make 6 pi. The middle of that period is 5 pi. The average of or midpoint of 4 pi and 5 pi is 9 pi over 2. And the average of 5 pi and 6 pi is 11 pi over 2. So now I'm going to continue my second period. It's starting here at 0. I'm going to go up to a maximum of 9 pi over 2, 1, back down to my 0, down to another minimum of 11 pi over 2, -1, and back up to the 0. So knowing the shape of the parent function makes transforming it much easier.